We're going to have a look at some a myriad of different techniques today that I thought might be useful to share that sort of go beyond the traditional introduction or sort of feature showcase stuff that I've been doing the last couple of years in showing off stuff we've been doing in web forms. So we've got a whole bunch of different demos showing a bunch of different techniques. So hopefully something in here is useful to those that are going to be watching either today or the recording later on. So first thing, as I said, we've got a list of things to go through, so I'm just going to go through them in no particular order. If you open a file new project today in Visual Studio 2012, you'll note that we've done a lot of new work on the templates. And obviously, we've also done a lot of work to ensure that the three frameworks have a very similar experience in their templates. One of the drawbacks that has been leveled at web forms in the past has been this concept of the server form, where basically nearly all web forms controls are required to be inside a server-side form. That's a form tag with runner equals server. And by default, our templates are set up such that the form tag essentially surrounds the entire body of the page. And so in the master page, if you have a look in there, you'll see that immediately under the opening body, we basically open that form runner equals server, and then your entire content is in that server-side form. And while that certainly is functional, it may not always be desirable. The form has special semantics inside the web browser. For instance, if you have more than one form on the page, when you place your cursor inside a form field inside a particular form tag, by default, the enter key will be mapped to the first submit button in that form. In web forms, we actually have to sort of special case the fact that we're going to have one server-side form with lots of different buttons potentially, and we have this concept of default button, and we actually have to emit JavaScript in order to capture the event when you hit the enter key and click the appropriate button that you set as the default button. A lot of the times though, you really don't need a server form for certain types of things. A classic example is if you have a search box in the top of your header, and all you want to be able to do in that search box is have people type in a phrase and then hit enter and have it post or actually do a get to a different form in your site, perhaps with the query term in the query string rather than it being a post and going through in the form collection, then that's a really great case for just a standard client-side HTML form. But by default, you're not able to do that because you can't nest forms. You can't have a client-side form inside a server-side form. So a technique I've used in the past to some success in other sites is to have a staged master page layout. So rather than having the server form in the root master page, you have it in a derived master page. So in this case, I have refactored this project slightly such that I now have a site.noform.master. So the site.noform.master is, as you can probably expect or tell, is a master page that contains the core layout of my site, and then doesn't contain a server-side form. It contains a content placeholder for the head. It contains a content placeholder for stuff you want to go inside the body, but then it's up to another master page or indeed a content page itself to be in control of where that server form goes. And so I have site.noform.master, which has all the styling and etc. that my application has to have. And then I have site.master, which itself uses site.noform.master as its master page. So now I have nested master pages. And site.master has the server-side form with the script manager directly inside of it, because the script manager has to be inside the server-side form, and then the rest of my framing content. And then content pages will generally derive from site.master if they just want to do standard sort of web form stuff. But if you need to have pages that require perhaps no server controls, or you want to have a client-side form inside that page, then you would derive from site.noform.master, you would have a page that sets site.noform.master as its master page, and then that page can have full control over where the server-side form tag goes. So that's the first tip. The second thing I want to talk about is the script manager. So in 4.0, we added a bunch of features to the script manager to allow remapping of scripts from one location to another. And you can see that in effect in the new WebForms templates, whereby in the script manager definitions here, we're actually remapping these core WebForms scripts like WebForms.js, WebUI Validation.js, etc., out of their usual location, which is they usually get served by scriptresource.axd out of the system.webassembly, and we're telling it to actually render them directly from a location on disk. And then if you look in the project, you'll see that under the scripts folder, there's a WebForms folder and an MS-Ajax folder, and we actually have all of the WebForms and MS-Ajax scripts in your project. And the advantage of this is that we can then use the new bundling support that's part of the optimization package to bundle up these scripts at runtime into logical bundles. And you can see that actually listed here. So you can see at the very top here we have a reference called MS-Ajax bundle, and we have a reference at the bottom called WebForms bundle. And if I jump into my bundle config, you'll note that I indeed have a bundle being set up by the standard bundles API as bundles WebForm.js, and another one as bundles MS-Ajax.js. Now you might be wondering why these names here are different to these names here. And the reason is that these script references are referencing declared script resources. And this is the same way, as you can see immediately afterwards, that we're referencing jQuery and jQuery UI.combined. Now, this is all customizable, so I wanted to show you how you can change some of these things to perhaps, for example, serve jQuery from the Google CDN as opposed to from the Microsoft Ajax CDN. So I'm just going to flip the CDN support off for a moment, and let's run the site up. Drag it over from my other monitor. Okay, so we've got the site running in here. I'm going to bring up my network, my developer tools here and look at the scripts folder. And we can see that my scripts are being rendered. I have jQuery 172, which is coming from localhost. I have jQuery UI Modernizer, and then here are the two bundles, MS-Ajax.js with the cache-breaking key on the end, and WebForms.js with its cache-breaking key on the end. So that's everything that we would expect. So let's go back and turn on the CDN. And before I do that, I'm just going to jump into my global ASAX, and I'm going to comment out a line of code here so that we can go back to the default experience that we would get out of the box for a new template, for a new project based on the templates. So what we can see now is that what's changed over here is we're now serving those two bundle files are now coming from the Microsoft Ajax CDN. You can see this down the bottom. So we actually took those bundled core WebForms and MS-Ajax script, saved the bundled JavaScript file, and pushed them up onto the MS-Ajax CDN, so that when we register them with the script manager and you turn CDN on, you actually get the benefit of all those scripts coming from the CDN as bundled up scripts rather than lots and lots of different references to all the various scripts. You'll also see that jQuery and jQuery UI are being served from the MS-Ajax CDN as well. But what if you want to serve these from a different CDN? How do you go about changing that? So I'm going to come back into my global ASAX. You can see that in application start, I've got a call to scriptconfig.register scripts, and I'm passing in scriptmanager.scriptResource-mapping. So scriptmanager.scriptResource-mapping is a property that we added in 4.0, and we've slightly extended in 4.5 to have some new features. So if I go through and just F12 on script resource mapping, not that one, on register scripts. Register scripts is a method inside my application. It's over here in app.start inside my script config class. Now you may see this app.start folder being used more and more for us to place code into that runs during the application startup lifecycle, part of the lifecycle. So you can see what I'm doing here is I'm remapping a definition for jQuery, and I'm remapping a definition for jQuery UI.combined by passing in a new script resource definition with all these properties set. So out of the box with the new templates, we have a definition for jQuery automatically set up for you because it's referenced via a package. If I open packages.config, you'll see that there's four packages here that are referenced that start with Microsoft.scriptmanager. There's one for jQuery, one for jQuery UI, one for MS-Ajax, and one for WebForms. And these are the packages that actually contain this mapping.add definition code that defines jQuery, jQuery UI combined, and the other files so that you can reference them in the script manager just by name. The advantage of this, obviously, is that it contains a lot more information than a single path. We can put in here the normal path, the path to use while debugging. We can put in the same, but rather up on a CDN. And then we have this new property that was added in 4.5, which is the load success expression. The load success expression allows us to render fallback logic so that if you have the CDN turned on and then loading from the CDN fails for whatever reason, then we'll go ahead and fall back to rendering the script from the local path instead. And so now that I've uncommented that, I'm going to rebuild, and I'm going to go ahead and run this page, and we'll see exactly what this looks like. So let me F5. I'm just going to refresh this same page again. And what we'll see down here in the lower left-hand corner this time is that I've still got some scripts being served from the Microsoft Ajax CDN. We've got my MS Ajax bundle, my WebForms bundle. Note how that ajax.googleapis.com is now being referenced because I remapped jQuery to be served from the Google CDN. But note that jQuery UI is being served from localhost. If we go back to my code, I did say to jQuery UI, I want you to come from the CDN. See, I've got a CDN path in here. But it turns out Google doesn't actually have version 1.8.20 of jQuery UI on their CDN. They only have 2.1. And so what has happened is that that has failed in the browser, and then the logic that we rendered into the client has taken over and loaded it from your website. So if I go over to the network tab here, we can see the failed request to the Google CDN for jQuery 1.8.20 if I just move that across. And so where did it come from? Well, if I go to my source and I scroll down to where these are actually referenced, this is what we've rendered for you on your behalf. This is what the script manager can do now in 4.5. And so here is the call to say, standard script tag, go ahead and try and load this from the Google CDN. And then immediately after that, we have a bit of JavaScript, and it says window.jQuery and window.jQuery.ui and window.jQuery.ui.version is equal to 1.8.20. So that is the success expression. That entire expression has to equate to true. Otherwise, everything on the other side of this OR operator here is going to execute. And what you can see we're executing is a document.write, and then we're writing in a new script tag that points to the local jQuery UI path. So this way, even if the CDN is down, you're still going to get these resources served because you have a copy of them that can be served from your local site, which is kind of nice. And as I said, it is set up to do that out of the box now in the 4.5 templates. However, if you want to serve from a different CDN for something like jQuery, you'll have to go in and do what I've done here, which is remap those script resources away from what they're currently set up to the new path with the new information that you want it set to. Okay, so that's the script manager. Let's look at some interesting pattern type stuff now. So some people might be familiar with the concept of the command pattern. This is quite popular in WPF and Silverlight, where we have the idea of, rather than having lots of click handlers and event handlers that have code directly tied to controls, and then having logic inside those handlers that actually does business logic or does UI logic, we set up this concept of a command. And the command can do whatever you like. It's a very, very simple interface. And then you wire up UI elements to this command such that when the UI element's main event fires, so if in the case of a button it would be something like click, when that click event fires, rather than going and finding a click handler, it just says, hey, delegate to this command, and then go and run execute on that command. The other advantage of this is it means you can have multiple UI elements that are bound to the same command in such a way that they do the same thing. This is very useful in a lot of UIs where you offer more than one way to do the same thing. And so ASP.NET Web Forms actually has a commanding system built in, but it isn't the same as the ones that you may have seen WPF and Silverlight, but we can leverage some of this built-in support in order to implement a pattern that's very, very similar. So I'm going to show you something fairly rudimentary, and the idea is that if you find this useful, you can go and explore this technique a little bit more and see if it's useful for you. So what I have here is a standard ASP button. I haven't subclassed any controls here, and a standard ASP link button. What I've done is I've set the command name property to the name of some command that I've set up in my project. So here I have AdvancedWebForms.UpdateLabel is a command that I've created, and we'll have a look at that command in just a moment. And then I'm using the command argument property, which again is a standard property of the button and the link button, to pass in this case, the ID of the other control that this command needs to do its work. So let's go to the code behind this page and have a look how I did this. Now note, my command page itself has no code behind. And so one of the things that you'll see recurring as I go through this talk is that I really try to drive to remove as much code as I can from the code behind of my page. In my mind, you want to ensure one of the biggest problems with web forms is ending up with a lot of code that interacts with controls. That code tends to be very brittle. It tends to be hard to change. And you're generally much better off trying to introduce some separation of concerns, whereby you use declarative statements like this, where you declare that this link button should go ahead and be wired up to the command called update label. So use declarative statements to wire up server controls to behavior or to data. And luckily we have a great data binding system that helps us to do that. And then use imperative logic factored out into different classes that don't actually interact with the UI, if you can at all help it. The advantage of that is you don't have lots of code that's touching the UI elements, which I said can be brittle and can be somewhat painful, especially with the complicated lifecycle of web forms in a page and the event system. It also opens up that type of code to testing as well. And so underneath this, you'll note that I've got my update label command, which has a single method execute. And underneath that, you can see the iCommand interface that I've created. So iCommand just has execute, and in this case, I've chosen to pass in a bunch of context to every command as it executes. So I tell it the page it came from, I tell it the control that was bound to this command that caused it to execute, and I give it some arbitrary argument that it can, each command can do whatever it likes with. So in the case of update label command, which again is a very simple example, I go to the source control, I navigate up to its naming container, and I say find control on the argument that was passed in, assuming that that's going to be a label. And if it's not a label, I return. And if it is a label, I go ahead and update it, saying I was updated by the update label command via whatever type of control was bound in this case. And then the actual logic to sort of wire up these commands to the execution, I've baked into a base class for a page. So remember, when you create a page in ASP.NET, I mean, if I go back to my default page and look at the code behind, by default, we inherit from system.web.ui.page, but you're free to make your page classes inherit from whatever you like, as long as that class inherits itself from page ultimately. And so I have a custom page base class here called command page, and it has a little bit of code in it. You can see what I'm doing is I'm handing the I'm overriding the on bubble event. So web forms has this idea of event bubbling. In WPF, this is known as routed events, where they can have tunneling events and bubbling events. And of course, you'd be familiar with this in the DOM as well, whereby a click event on a button can bubble all the way up to the body or even the HTML element, and you can handle it there. In fact, jQuery uses this a lot with its delegate method that you can use for wiring up events. So web forms has this built-in feature, but generally only control developers use it. This is how things like the grid view work. When you can place a button with a command name of update in the grid view, the grid view itself handles or overrides on bubble event because it's derived, it's specified on the control class, and then it determines whether the event that is bubbling up through the hierarchy is one that it cares about. And if it is, it handles it and returns true to say that we've handled it. So in this case, what am I doing? I'm grabbing the event args as command event args, because by default, what the button will do, if we go back to my markup, what the button will do by default without me having to do anything is when I click it, if the command name is set, it will force that command event to start bubbling up through the hierarchy of the page. So now I'm handling that by detecting whether the event args were command event args. And if they are, I'm going to go ahead and find the iCommand implementation that maps to the command name that was passed in the button. So remember, in the command over here, I have command name equals advanced web forms update label, and then I'm just using a little convention to add the word command to the end of it. And so then I'm calling into ASP.NET's build manager, and it's going to go ahead and find me update label command, because that's the type that maps to the string that I pass in as the command name. And so then if I can't find it, I just continue the event bubbling up. If I can find it, I go ahead and call activator.create instance. Now, of course, this is a simple demo, so I'm just using the standard ways of doing this, but you could use any fancy dependency injection framework or other ways of creating classes here that you would want to if you wanted to inject any other state. And if that's null, then obviously I continue. Otherwise, I go ahead and call execute on this command, passing in the page, the source element that caused this, in this case a control, and then the command argument from the event args as well, and then tell the event system that I've already handled this event and it can stop bubbling it. And so now if we run this, let's run this up. So I have my link button and my button that are both mapped to the same command. And so I can click do something, and you can see I was updated by the update label command via button. And if I click do something as a link button, it says I was updated by the update label command via a link button. So yes, it's a very simplistic example, but it just shows how you can utilize some of the existing eventing support inside web forms, because after all, it is a component-driven, event-driven paradigm when you're doing web forms development. You can leverage that to help clean up some of that code behind that we all sort of hate so much. As I said, we really don't want to have code in the code behind that's interacting with the UI if we can help it. If you do have to have code that adjusts controls in some way, I would recommend that rather than putting it in the code behind, put that code in a subclassed version of the control, if at all possible. So again, there's nothing wrong with subclassing something like a repeater or a grid view, and then you can either register that as a custom control and place that in your app, or you can use the features like tag mapping to replace all instances of something like a standard repeater with your repeater, which has its custom logic, as long as your repeater derives from the standard repeater. Now, if you don't know what tag mapping is, you can go ahead and sort of look at that. Let me give you a quick example. So ASP.NET tag mapping element for pages, and it shows you how you can go ahead and remap existing tags. So ASP::grid view, for example, remap that to your grid view control, which subclasses the inbox grid view control. It can be very, very useful if you find yourself writing code in the code behind of many pages that you use to manipulate controls. Let's get that code out of the code behind and get it in the place it belongs. Okay, so that is commanding. Let's move on to something else. So one of my favorite features that we added in ASP.NET 4.5 is one that lets you customize the compilation system. Let me create a new form here, and I want to just quickly explain how stuff works. So I'm going to call this watch this compile. And inside this, I'm just going to put in an invalid code block. So I've created a code block, I put the letter F in it, and I'm going to run this. Now obviously I'm going to get a compilation error. So what happens when you hit an ASPX file for the first time is ASP.NET dynamically compiles that markup into a class. And what we're seeing here is a compilation error, because I've injected a code block that contains invalid C# code. So I've purposely brought up this yellow screen of death because on your local box it has this really interesting link, which is show complete compilation source. So if I scroll down, what we're seeing here is the actual class that got generated from my markup. And so there's a lot of ugly looking stuff in here, because this stuff obviously has to be set up to allow things like debugging, so you can set a breakpoint inside those code blocks and have Visual Studio step through it. But what you can see is that, at the end of the day, your page just gets turned into code. It's a standard C# code, and we can see that things like my page directives have been set up as various properties that are set on the page. And as I scroll down, you can see various controls being created. You can see various methods being set up. So build control content 1 that will get called at a certain page in this page's lifecycle. And somewhere in here will be my erroneous error. So if I come back up to the top, Let's give it a better name so we can find it. So this is an error. Let's come back. F5 on that. Come here. Let's find it. This is answer. There it is. So we can see here that that line ended up in a method called @__render_content2, taking in the HTML text writer. Because I just put this code block directly inside the content of the page, it's literally being pasted into or generated inside the render method as such of this page. So we added ability in 4.5 for you to change what type of code gets generated here on the fly. So let's back up a little bit. You've always been able to affect what code gets generated. If you have something like a repeater, and then inside your repeater, you have an item template, and then inside the item template, you have a data binding expression. Something like, eval, let's do foo, okay? This generates more code inside of your code behind. So let's put another mistake in here. And let's come back, F5 on this, and let's have a look at what got generated. So let's have a look for my call for eval. There it is. So you can see that inside @__data_bind control 6, you can see that the container is a repeater item because I'm inside a repeater, and the target is a data bound literal control because I'm not actually assigning the value of this data binding expression to a server property. I'm just putting it inside the body of the template, so it automatically gets converted into a literal control for me. You can see down here that finally target.setDataBoundString is being called, and it's passing in this eval foo, which is the expression that I wrote in that should be the result of this data binding operation. But you're very limited as to what you can get inside this method. The only way that you've been able to change this method in the past is to build a custom control builder. So if you're a control developer, you can go ahead and build custom control builders such that when the compilation phase finds this tag and starts building up the code to generate it into the class, you can be called into with the code DOM that's going to be emitted, and then you can edit that on the fly. The problem is that if you wanted to affect the code generated by an existing control, say you wanted to affect the code generated by the repeater or the grid view, you couldn't do that. You would have to subclass the repeater, and then you would have to basically re-implement the control builder, adding the stuff that you wanted to add. Well, that's no longer the case. We have added a new thing called a control builder interceptor. So let me go and show you what a control builder interceptor looks like. So this is my control builder interceptor. And let me bring you up to a page first. So the idea of this control builder interceptor is I want to add a property called autobind to every single control in the framework. But for the purposes of this demo, let's limit it to the panel. Now usually, if I wanted to add my own property, I would have to subclass the panel, and then I would have to use Damien's derived panel, and then the autobind property obviously would just be a standard property that appears on that class. Well, with the control builder interceptor, I can actually add this property sort of in a late bound fashion by intercepting the stage where this control gets converted from markup into code. So let's jump across to the interceptor and have a look at how I would do that. So I derive from the new abstract base class control builder interceptor, and then I get two methods: pre-control builder init and on process generated code. And what happens is on pre-control builder init, I determine whether a type, which is one of the parameters that's been passed in, is a panel. So is the thing that I'm trying to build a panel? If so, let me find the autobind attribute out of the list of attributes that has been passed in. So at this stage, this control is just a panel that has a bunch of attributes. So let me find the autobind attribute. If it's there, go ahead and remove it from the attributes collection so that the panel control's own control builder won't see it. This is something I'm just now going to take out and use for my own purposes. Then try and parse the value of that attribute into a Boolean, and if that succeeds, go ahead and add that to this additional state bag that was passed in for me. So you can see that the last property here is a dictionary of additional state, and you can use this to store any state required while doing your custom control builder action. So now that I have the state inside the control builder, I can go ahead and say on process generated code, which is going to get called back into me at the right stage in the life cycle. It's going to pass in that extra state again. So I can simply say, well, first check, I'm going to do a quick null check, grab that auto bind property from my additional state bag, and then if it isn't null and it is a Boolean, cast it to a Boolean, and then go ahead and add a new code statement into the build method that was passed in. So note what's passed in here. One of these methods, a whole bunch of stuff, is this thing, a code member method, a build method. This is the method that we saw behind just a moment ago in that compiled page that is actually going to get executed when my page is accessed. So I'm having a chance to actually change this method on the fly when this page is compiled. And so I'm cheating here. I'm just using a code snippet statement. It's the easiest code DOM primitive to use because I can just paste some C# code in here. But obviously the C# code wouldn't work if I was doing this inside a VB ASPX page. So generally you would write this using proper code DOM, using the abstractions that the code DOM provides you to build code on the fly. But for the purposes of the demo, this makes it very easy to see what's happening. I'm inserting a method in the line before the final line, and I'm saying on page pre-render complete, run this event handler, and the event handler is just calling data bind on at __ control. So at __ control is the member name that gets generated automatically by ASP.NET that represents the current control inside this build method. Okay, so let's introduce an error into this page so that we can see this output. Okay, let's build that. Okay, so there's my error. Let's jump down here and let's see if I can find this call to data bind. Okay, so there's one call to data bind. There's another one. So here it is. Here is my line that I added dynamically by way of the control builder interceptor. And it's inside the build method, which is build control control3. So that was the method that was passed into my control builder interceptor that I was able to edit. So pre-render complete, now this control will automatically data bind itself when the page has got to the pre-render complete phase. Let me come back and get rid of the error. Let me quickly show you how I actually told my project to use this control builder interceptor. So I go into my web.config, just wait for the screen to refresh, there we go. And then on the compilation section, you'll see that there's a new attribute which is control builder interceptor type, which I've set to my auto-bind control builder interceptor. So you can only have a single control builder interceptor registered for your entire site, but it will get called into for every single control building operation that ever happens in your website. So you're free to build your own composition model on top of essentially this singleton object, because we're going to new this up for you and it'll live for the life of your project. For your application. You're free to build your own composition model on top of that. For the purposes of this demo, I've simply just created one called AutoBind, and all it does is enable AutoBind on a panel. And so now, if I go back to my page and I hit F5, everything seems to work. If I hit toggle content, you can see that this label says this content is conditionally shown. If I hit toggle content again, it turns it off. Well, why is that significant? Well, let's come back to my page and see what I'm actually using. So I talked about this idea of knowing when to use declarative statements in web forms versus imperative statements. And I said that it's generally when you're setting the properties of server controls imperatively, that's a bit of a code smell. You're going to end up having code in your code behind that's interacting with some data and then going through and doing a bunch of property updates on controls. You should really try and avoid that. Web forms has a very rich data binding system built in, which is designed specifically for doing this type of stuff. So you can set the property of a server control using a data binding expression, but you can't set it using a response writing expression because they happen at different stages in the life cycle of the page. So in order for this data binding expression to be executed, I have to force this panel to data bind because it's not inside a template inside a data bound control. I'd have to either manually call data bind on the control, which means more code on my code behind, or I can simply implement something like auto bind with a control builder interceptor so that it does it automatically. So if we have a look at the code behind, I have a property. You can imagine this is basically my model. And for the purposes of the demo, I'm just storing this model is being backed by viewState, but don't freak out about that. This could obviously just be a model type that you create with a whole bunch of properties. It could be pushed in from some service layer. Don't get hung up on the fact that I am storing the model in viewState. So I have a Boolean of some condition, and then you can see when I click the button, rather than me interacting with some control, I'm simply setting some condition to the opposite of what it already is. And then for the panel itself, its visible property is set to the current value of some condition. And so now the panel will just toggle on and off without me ever having to interact directly with the panel. So again, this is about creating a layer of indirection between my logical code and my code that controls my UI. And the ultimate sort of extension of this is using a full-blown presentation, a separation sort of pattern framework like WebForms MVP, so that you really have very, very little code talking to controls. But there are ways you can do this, like with the control builder interceptor, that let you do some interesting things. Now, you can take this to a really, kind of real extremes. Let me just open another sample here that takes this idea to an extreme. So David Fowler, one of the great devs on the ASP.NET team here, wrote an interesting demo application, a demo system a couple of years ago, which was a completely custom data binding system for web forms. And it used the WPF style data binding syntax to enable you to set up relations between controls using that type of syntax. So here's my page, and you can see that I have a text box, and its text property is set to this odd looking text. But anyone who's done WPF or Silverlight will recognize what this is. So this is a data binding expression where I'm saying this is a control binding, so I want you to bind the text value to a control called options and use the property selected value on that control. So here's my control called options, and selected value of a drop-down list will obviously be whatever value I've chosen from here. If we go into the code behind, you can see that there's no code inside of here except an example of setting up a data binding imperatively. So again, this is something you can do in WPF and Silverlight, but you can't do with WebForms data binding out of the box. You can only set up data binding declaratively. But in this data binding system, you can add data binding imperatively. So you can do it conditionally if you want to do so. And that's just an example of doing that. But otherwise, there is no code in the code behind. And so I also have some other examples. I have a text box here, which has its text mode property, rather than its text property, is being bound to a radio button list. So we're basically going to flip this text mode between multi-line password and single line based on the value of the radio button list. And we've got some other values, some other examples here of binding. So if I run this up, so here we go. We can see that the value of the text box was set to 1. If I change it to 2, it changes to 2. If I change it to 3, it changes to 3. You can see that the multi-line text box's enabled property is being bound to this checkbox down here. So if I tick it, it's now enabled. If I check it, it's now disabled. Similarly, if I flip through the different modes here, you can see that it's changing from a multi-line text box to a password text box to a single line text box, all without any code in the code behind. These are all declarative statements that say, I want this property on this control to be bound to the value on this control. So here's another example. I have a text box, I have a drop-down list with values in visible and visible, and when I choose visible, the value, the control on the right is then set to that value. So just a really advanced scenario or advanced demonstration of what's possible now that you have access to the compilation system in WebForms. And the way he implemented this a few years ago, but he had to do it with custom controls. In 4.5, we've rewritten this demo to show that you can now do this type of thing with standard controls. So he's been able to hijack the data binding system as such by injecting his own custom code into standard controls. And if we look in the web.config of this page, of this project, what you'll see is the control builder interceptor type is set to this web.binding.bindable control builder. So with a custom control builder, he's able to get involved in the the compilation step of every single control that goes on in this application. And as such, we've been able to build a completely custom data binding system, which may or may not be interesting, but it just shows you the sort of level of power that you can get now by using this new feature. Okay, so let's look at one of the other new small compilation features that we added. So custom templates. So this was actually an item that was voted on user voice, and so we did this work item to make the 70 or 80 people that voted on this item happy. I have a list view here, and I notice I have no template in my list view. So there's no item template, there's no edit item template that has been set. If I go into the code behind here, you'll see that the item template is actually a string inside my code behind. Now you can imagine that I could be getting this string from anywhere. It could be coming from a database, it could be coming from files on disk which I load. The string could be coming from anywhere. The point is that the template itself is now just a string. And then in PagerNet, I'm now setting the item template property of DataListView to the result of calling templateParser.parseTemplate. So templateParser.parseTemplate is a new method that we added in .NET 4.5 that lets you take an arbitrary string of ASPX markup and return an iTemplate. And that iTemplate can then be assigned to the existing properties on the various data controls, like repeater and list view and grid view, so that it uses that iTemplate for rendering. And so then you can see my data method here, I'm just returning a new list of categories. So if I run this page up, you can probably imagine what's going to happen. I get my template being rendered over and over, but my template was being set from code behind using a string rather than it being declared inside my markup. And so again, another example of making a choice about what should be imperative and what should be declarative. Declarative is fantastic if you know all the conditions up front. And I certainly am a big believer in going declarative if you absolutely can, because I think it makes stuff more maintainable if it's used in the right way. But in some cases, you need to go imperative because you need to set stuff dynamically at runtime. And so something like this is very, very useful for doing things just like that. So that's custom templates using templateParser.parse. Let's move on to some of the new model binding extensibility features. So you may have seen me talk about model binding previously in some of my other ASP.NET 4.5 talks. What I haven't shown a lot is how you can extend the model binding system. So the model binding system is built very similarly to the one in WebForms. We have the idea, in MVC, we have the idea of model binders, and we have the idea of value providers. And both of these things are pluggable. And so what we have here is an example of a custom value provider. Now we ship with a number of value providers out of the box, including value providers for retrieving values from the query string, the cookie, the form, and you can see those in use right here. What this value provider is an example of an aggregate value provider, and is designed to give you a value provider that behaves similarly to how the default value provider in MVC works, whereby when an MVC action method is being resolved and model binding is trying to inject values, by default, it's going to try and retrieve values from the request. So that may be from the query string, from a cookie, or from a form value. Now in WebForms by default, you have to actually decorate every parameter in your method, telling us explicitly where you want that value to come from, whether it be from the query string, from cookie, or the form. But if you want it to come from anywhere in the request, this is what you can do. You can create a custom request value provider. It implements the two value provider interfaces that are in the base framework in system.web.modelBinding, iValueProvider and iUnvalidatedValueProvider. And then I have a read-only list of value providers. These are the value providers that I want to actually enumerate through until I find a value. When in the constructor, I go ahead and add the three value providers that I actually want to be the real value providers behind my aggregate value provider. In this case, query string, cookie, and form. And then I implement contains prefix, and I say if any of my value providers contain that prefix, then return true. And then I implement get value. This is get value on the iValueProvider interface, and then I've got, which just delegates through to get value on the iUnvalidatedValueProvider. So the difference between these two is one of them supports reading from the unvalidated request collection, which bypasses request validation, and the other one just reads from the validated request validation collection. And so I pass in false, And so it ultimately calls this one saying skip validation, but in the case that the I unvalidated value provider is passed, then it's going to pass in true potentially, so that it gets it from the unvalidated collection. Now, incidentally, each one of these value providers does implement I unvalidated value provider. The ones we ship in the box do that. So then when get value is called, I loop through all my value providers just using link, and I say get the first value from any of these value providers that matches the given key and the given skip validation flag. And so now I can use this value provider in a data method in order to get the value from either the query string, the cookie, or the form in that order. I don't really care where it comes from. So the second thing I would need to do is create an attribute that I can use to decorate my model binding methods with. And so that's very, very simple. We provide you a base class, value provider source attribute, and all you have to do is implement get value provider. We give you the model binding execution context. You return us a value provider. And in this case, I just return a new instance of the request value provider, which was the class I created over here. So let's have a look. That's the code to actually go ahead and build one of those things. Let me go ahead and actually show you a page that uses that. So I'm going to switch over to a different project, which has a whole bunch more code in it. And let me show you an example of where something like this might be useful. So keeping on the topic of advanced model binding, we have this concept of ad hoc model binding. So I'm just going to come into here. I'm going to find where I'm calling this from. Okay. So in this case, I have a page that wants to use the model binding system, but doesn't want to use data controls. You've probably seen me give demonstrations about how to use model binding with data controls. Let me show you a very quick example of that. Here's a categories page. It has a grid view. I've set the item type to category. I have a select method of get categories, and then in the code behind, I have a method called get categories, which returns an iQueryable. So that's all good and well. And if I were to put parameters on this get categories method, then the model binding system would go and populate those parameters with values from the desired value providers. But what if I want to use providers and model binding without using data controls? What if I don't want to use a grid view or a list view or a repeater? We call that ad hoc model binding, and we do support that. And so here's an example of a page that does that with a little bit of more customization to make it kind of usable. And so if I just look at the markup for this page, let's find my ad hoc model binding to an anonymous type. Here it is. I have a field set which has an input, so I'm not using a server control, but I want to use model binding. So name equals first name, and I'm saying value is equal to model.firstname. And then I have a button which says click me, which forces a post back. So if I go to my code behind, you'll see I have a model, which is dynamic. And then in page load, I'm setting that model equal to model binding execution context dot bind to this anonymous type. So this is completely custom. This is something that I've built based on the model binding system inside of WebForms in 4.5 that lets me model bind against anonymous types. So what is this method going to do? It's going to take the anonymous object that I've passed in, and it's going to return me a new object that looks like this object, because I can't new up anonymous objects. There's no type. In fact, the constructor of these is internal, so you can't do that. But I can certainly return a new object that looks like this object, and do it wrapped in a dynamic object so that it doesn't matter what member you try and access on that object, it'll always return a value. So let's have a look at what this model execution context.bind method does. So this is a method I created. It's in a file called model binding extensions. Again, this code will be available, so you can have a look at all this afterwards to see these crazy things I've been doing. And so I'm hanging this extension method off the existing model binding execution context type that exists in WebForms. And you'll note if I go back to this page, that is actually a property on all pages in 4.5. So I'm able to hang extension methods off that property, which is a really, really nice way of sort of adding further functionality without having to new up new types in your code. So it takes in a model of T, and then it creates a new aggregate value provider. So this aggregate value provider is exactly the same as that request value provider that I just showed you before. So this is a value provider that's going to try and get values from both the query string, the cookie, and the form anytime a value is asked for. And then I'm going to call bind from value provider, which is a public extension method again on model binding execution context. I'm going to grab the default binder off the registered model binders. I'm going to new up a binding context, which again is a type that's inside the model binding system in WebForms 4.5. Set a bunch of properties. Now, these properties are being passed either from the context that's being passed in, or from the value provider, which is a parameter that I passed into my custom method. And then I go ahead on that binder and call bind model, passing in the context and the binding context. And then I return a custom type, which is dynamic model. So this is the object that's actually being returned from the model binding system. So in this case, I'm returning a dynamic object. And if we have a look at my dynamic module type, it inherits from dynamic object. And when it implements get dynamic member names and try get member, it's just backed by a type, which is the model type. And it uses get members on that model type. So when you say on this model.firstName, if the type that you based it on has a first name, then obviously it'll be there or not. So when you finally go and call try get member, I just look at the underlying model that was passed in and use reflection to grab out that value if it's there, otherwise return an empty string. The end result of all this is that I can have a dynamic property in my code behind called model. I can access any member on that model because it's actually all late bound. This is a dynamic object, and I simply late bind to whatever you put in here as the property name. And if it doesn't exist, I return you an empty string. So it's always safe to bind against what you put in here. So if I run this up, I get an error, which is always nice. Okay, yes, I have seen that error before. I haven't updated this sample for the latest build of 4.5, but I will do that when I check it into GitHub so you can see the code. We made a change in underlying API that causes this error. So that's fine. So essentially what will happen, obviously, is when the page is first hit, I'm going to end up getting the value of this text box being empty because model.firstName will return an empty string. And then when I type in a value and hit click me, when the page re-renders, the model.firstName is going to be set to the value that I put in the input because it also has a name of first name. So when the model binding system runs, it's going to find first name in the form collection, it's going to push it onto my dynamic model, and then when I re-render, model.firstName is going to echo back the value that I entered in. So this is a really, really great example again of how you can extend the underlying model binding system. If you don't want to use data controls for whatever reason, you can use the power of the model binding system without data controls. You don't have to use your grid views and your list views and things if you don't want to. You can use standard HTML and response writing expressions like this, and then create extension methods that call into the underlying model binding types and system so that you can get the advantage of the model binding system doing what it does best. The model binding system is designed to take user input from the request in the form of a string and then dynamically turn that into strongly typed data. That's what it's really, really good for. So you should definitely be leveraging that if you can. So the last thing I wanted to quickly show was using dynamic data along with model binding to again try and separate out and tease out the different parts of your application, being application logic and the parts that make up UI. So I have down here, let's have a look at this form here. This is a categories repo DD edit. So I have a form view. I'm back to using data controls now. Using model binding, select method equals get category, update method equals update category. And then you can see that in my edit item template, rather than me having a list of all the members that I want to be bound onto item type, I'm relying on the dynamic data system that we shipped in the box in 4.0 and that we enable by default in 4.5 for any data control that has its item type property set. I'm using that to have it automatically generate UI for me for the category object. So if I go to my category object, which is inside my model, you can see that I've decorated my category object with data annotations, just like you would do when using Entity Framework, MVC, or Silverlight. And then at runtime, what's going to happen is the dynamic entity control is going to find an entity template inside my dynamic data folder. So this dynamic data folder came down from NuGet. It's a standard dynamic data package that contains the entity templates and field templates that are included in the box. So I installed those and then I customized them to make them match the markup that I like. And so in this case, we're looking at the edit item template. And so the default _edit user control is what will be used to render the UI for the category. And so you can see inside of this is an entity template. The item template for this is an LI. If we go back to my page, you'll see that I was surrounding this with an OL, so you can see why that's an LI. So for every field on this entity, I'm going to get an LI with a label and an instance of a dynamic control. Again, these are types that shipped in 4.0, but we automatically wire up for you with strongly typed data controls in 4.5. I'm going to put an instance of a dynamic control, which then is going to go into my field templates folder and find the most appropriate user control based on the type of the property that this LI represents. So in the case of a string, it's going to be a text edit. In the case of a date time, it's going to be a date time edit, etc., etc. And you can go in and manually edit these field templates so that everywhere a date time shows up in your application, this date time and date time edit user controls will be used. So if you want to use something like a Telerik date time widget or jQuery UI or Juice or something from a different control vendor, you can very, very easily do that just by editing these templates. So if we go back to the main page again, you'll see that my actual page markup is very, very small because all the logic for the UI composition is being handled by dynamic data and has been separated out into individual field templates which get composed on the fly. If I go into the code behind, you can see I have very, very, very little code. So again, I'm trying to reduce the amount of code in my code behind such that the logic, I'm letting WebForms do the heavy lifting of UI composition for me because that's what it's good for. The only code that I'm wiring up are some extension methods that I wrote that customize the model binding system such that instead of looking for the methods on the back of on my code behind file, it's going to look for those methods on my custom repository object. So this is another way that you can customize model binding in 4.5. You don't have to have the model binding methods in your code behind. You can have them on a custom repository class. In this case, I have something called category repository, and you can see it has a method called getCategories, it has a method called insertCategory, has a method called updateCategory, and they all take in a model method context. This is a context class that is provided for me by the WebForms runtime so that I can do things like add errors to model state and also invoke model binding by calling things like try update model. Again, very similar to how model binding works in MVC, but now I have all my logic in a completely separate class so I can unit test this freely. You'll be able to have a look at these extension methods. I like to create extension methods for doing this type of stuff. You can set this up in the markup. So if you have a look at what this extension method does, all it does is for the given data control, I handle the calling data methods event, and then I set the data methods object property on the event args to the passed in data methods object. I could absolutely do that the standard way by going into the page, handling that event by doing on data methods, called, etc., etc. But because I'm doing that a lot, and I want to do that as a pattern throughout my application, rather than having to do that every single place, I find that it's much cleaner just to have a nice extension method that I can call in PageInit that sort of sets up this categories form to the way that I like. And if I wanted to go one step further, I could even customize the form view by subclassing form view, handling that event in the subclassed one based on some other, and then passing in a value based on some other paradigm, maybe using an IOC container or dependency injection. And then I wouldn't even have to have this code in my code behind if I didn't want to. So the other extension methods I have here, which are kind of interesting, is redirect to route on item updated. So by default, if I flip back to markup here, by default, things like the form view, after you've hit something like the update button, they're going to do a post back to the page, the entity is going to be updated, and then they're going to re-render themselves inside the result of that post. Now, while WebForms is kind of geared to doing that thing, you don't have to do it that way. You can absolutely implement the post redirect get paradigm. And if you haven't heard of that before, if you do a search for post redirect get, You can see there's actually an article on Wikipedia about this, which explains the whole idea of post redirect get as a web development pattern. The basic idea is that when the user submits a form, you shouldn't be rendering a result in the browser as a result of that post directly, unless it's to show the user that there was an error, like a validation error. If everything succeeded, you should be doing a redirect to another page and then showing a success message on there. And that's exactly what I'm doing here. So I actually have different pages for the different types of forms. So if we go back to my solution, you'll note that I was looking at the edit form, categories repo dd edit. I also have categories repo dd new, which handles the insert case, and categories repo dd delete, which handles the delete case. And then I have categories repo, which actually lists in a grid view all of the items themselves, with links off to the various pages. So you can see the edit link here is going off to a route URL for categories edit. And so the route URL categories edit points to categories repo dd edit. So this is a very similar page setup to what you might get if you use scaffolding in MVC, whereby the edit, the update, the create, and the list methods are actually distinct action methods with distinct views in your project. You could absolutely do the same thing in web forms, and this project is an example of doing that. I'm even using routing to have nice friendly URLs to do so. And so then in my code behind, all I have to do is say, tell the categories form that when it is successfully updated an item, rather than re-rendering itself, redirect to the route called categories. And if I just look at the code that I've done here, I'm handling the item updated event. And then if the model state of the page is valid, I'm telling the page to redirect to the route that was passed in, that route name. So I'm using a lot of the concepts that were introduced in 4.0 and 4.5 together to tease apart the various concerns of my application so that my code is a lot more modular, easier to unit test and easier to maintain. And I'm leaving the heavy lifting of UI composition to the data binding and dynamic data system in web forms, using entity templates and field templates, so that my actual code markup is fairly limited. It's really only concerned with the actual responsibilities of this page. Okay, so that's everything I had to show today. I am going to be uploading all this code to my GitHub repository. There is a GitHub repository right there now with the beginnings of this. Let me quickly bring this up. So if you go to Damien Edwards aspConf 2012, there's the async code I showed yesterday in my async talk, and then this advanced web forms solution, which will contain all the code I just showed you. Please feel free to send any further questions you have to me via Twitter or email. I love talking about this advanced web form stuff. I'm really excited, especially about the control builder interceptor stuff that we added in 4.5. I'm really excited to see what people come up with now that they have full access to the compilation stage of controls inside web forms. So again, thanks for the time today, and have a great ASP Conf.